Having me. I'm really excited to be doing this. So I'm going to be talking a little bit about my most recent book, Flashes of Creation. And the questions I talk about in my book are ancient questions that have been around for millennia, such as, did time have a beginning? If so, what happened in the beginning of time? How did the stuff of the universe emerge? How big is the universe? And will the universe last forever, or will it someday perish? So until the early 20th century, there was no real way of answering these questions scientifically. So what you had was philosophers trying to debate the questions using logic, rhetoric, and thinking, but not really based upon actual evidence. So they didn't really get very far in answering the questions about the universe. But luckily, in the early 20th century, there were some major revolutions in science, such as relativity, quantum physics. And relativity applies to things that are very, very fast, high speed things close to the speed of light. And general relativity, which is a subset of relativity, applies to strong gravitational situations. And now we know about situations such as black holes. And quantum physics applies to things that are very, very small, atoms, elementary particles, and so forth. And we see two figures who are behind these revolutions. Albert Einstein, who played a role in both of these, in the quantum revolution and in the relativity revolution. He was the founder of relativity. And Niels Bohr, a Danish physicist who continued the idea of the quantum revolution by postulating the atom as a kind of a solar system model, and then later continuing to be kind of the godfather of quantum physics by fostering conversations and discussions about these ideas in his institute in Copenhagen, Denmark. Now, I'd like to take you back to the year 1915, which is a very important year. That's the year that Einstein's masterful theory of general relativity was published. And you see it was published in German on the left. And
Hi, Paul. I'm sorry to interrupt, but we can't see your slides moving. We still.
Okay, thank you. Okay, so 1915 was, and you just see the slide now. You don't see anything else on my screen?
Nope, it's just a slide. It's large. It's perfect. We can all see
Brilliant.
it. Yeah,
Wonderful.
keep going.
Okay, I'm sorry. All right, so in 1915, that was the year that general relativity, Einstein's masterful theory, was introduced. And it was also the year that the great British physicist Fred Hoyle was born in Bingley, Yorkshire, a town, Bingley, which is near Bradford. And you see the blue plaque of his birth house, which I had the opportunity to visit several years ago. Right before the pandemic started, I took a trip to England and went to Bingley and took a number of photos, which was good timing on my part. So Einstein's masterful theory of general relativity can be expressed very simply by saying space tells matter how to move, matter tells space how to curve. So that's one way of saying that that matter is going to warp space-time. It's going to indent it, kind of like if you had a trampoline and you placed a heavy stone on the trampoline, and the trampoline would stretch, warp. And then if you place something else in the trampoline, such as a marble, the marble would try to travel in a straight line, but the best it could do would be to travel in an elliptical motion and kind of an orbit, because as much as it would try to travel in a straight line, because of the denting of the fabric, it would start moving in an orbital motion. Now, Einstein, after he completed his general theory of relativity, he was rather unsatisfied because he tried to apply his theory to the universe itself, but every solution he got was unstable. It was either expanding or contracting. And as much as he tried to get a stable solution, he couldn't. And the reason he wanted a stable solution is because the Newtonian model of the universe says that the stars move, but the universe itself is not supposed to move. He thought that was an error of his theory because it said that the universe was actually getting bigger or smaller, and he thought that that was ridiculous. So he tried to tinker with the equations, and finally he added a cosmological constant term, which was an extra factor that was a bit like scaffolding to support a stable universe theory. It would be like taking a building that's about to topple over, like the Leaning Tower of Pisa, and applying scaffolding to keep it upright. It's not very elegant, but it does the trick. Now, around that time, a Russian physicist, Alexander Friedmann, who by training was a meteorologist, decided to tackle Einstein's equations, and he looked at the equations without the cosmological constant term. And he found some solutions which were expanding, and some of them would expand forever, and some of them would expand for a time and then start to contract. And these are called the Friedmann solutions. And interestingly enough, as a meteorologist, he used balloons to travel up into the sky, and his model is a bit like a balloon. If you imagine taking a balloon and painting dots on it and then blowing it up, the dots get farther and farther away from each other. So as you blow up a balloon, the dots would equally separate from each other. And that was Friedmann's model, that space would expand, and it would expand in a way that if dots painted on the universe would move away from each other. Now, at that time, there was no evidence for the universe to be expanding, so it seemed a little bit like a toy model, something to play with, not an actual model of the universe. But Friedmann was intrigued by these solutions. Now, one of Friedmann's students was somebody named George Gamow, who was born in Odessa, Ukraine, and then moved up to St. Petersburg, which was then known as Leningrad, to attend university. And he was a student of Friedmann in a class on general relativity. Now, Gamow wanted to work with Friedmann, but unfortunately, Friedmann, shortly after traveling up in a hot air balloon, he caught typhoid. We don't know if there was a connection between the two, but he got very sick at a young age and died at a young age of in 1925, and could not. His career ended abruptly. So Gamow couldn't work with Friedmann as a student, as a research student. Meanwhile, Edwin Hubble, an American astronomer, began to explore the heavens and aimed his telescope, the Hooker telescope at Mount Wilson Observatory, at the skies, and found evidence that the universe is expanding. That evidence came in the form of looking at galaxies, distant galaxies, and noticing that if you plot their distances versus what are called the redshift is an effect where light shifts towards the red end of the spectrum because the galaxies are moving away from us. It showed that all the galaxies except the nearby galaxies are moving away from ours. So either our galaxy did something really heinous to cause all the other galaxies to flee in horror, or more likely, the universe is expanding and that all the galaxies are moving equally away from each other. Now, little known fact, Hubble was also a fantastic basketball player. He led his team at the University of Chicago, so he was a true scholar athlete. Now, here's Hubble's graph, and you see that the farther away you go from our galaxy, the Milky Way, the faster galaxies are moving away from us. And that is evidence for the recession of the galaxies. And most scientists of his time accepted that as proof of the expanding universe. Hubble himself was a bit dubious about reaching a conclusion. He was very cautious and said that there might be possible other theories as to why the galaxies are receding, such as light losing energy. But most of his contemporaries believed that the universe was expanding. And that matched the Friedman model rather nicely. Now, shortly before Hubble made his discovery, Georges Lemaitre, a cosmologist and priest from Belgium, also speculated that the universe was expanding. And he developed models very similar to the Friedman models, in which the universe would expand from a small glob, and which he called the primeval atom. And here's a picture of Lemaitre with Albert Einstein. And Einstein became convinced by Hubble's evidence, not by Lemaitre's solution, but by Hubble's evidence, that the universe was indeed expanding, and realized that adding the cosmological constant term to stabilize the universe was actually a great blunder on his part, rather than needed. So from that point on, he eschewed the cosmological constant, dropped the term, and said it was a great mistake. Now here's Lemaitre's book, The Primeval Atom. Imagine that all the matter in the universe started as this giant glob, and then that glob exploded in what Lemaitre called cosmic fireworks. Now, meanwhile, Gamow did not receive his degree in studying cosmology, but rather he turned to quantum theory. And it was actually a good thing that that happened, because he was able to resolve a long-standing question that had perplexed scientists such as Arthur Eddington. How do the stars shine, and how do they create elements? And those turned out to be a related question. Gamow came up with the solution that protons in the sun and other stars can merge with each other in a process called fusion by overcoming the repulsive barrier between them, the repulsive electromagnetic barrier. And by overcoming their repulsion, they experience what's called a strong nuclear force that sticks them together, and these particles become other isotopes. An isotope is something like an element, but with different amounts of neutrons. And the isotope that two protons, if they get together, form, one of them transforms into a neutron, and then they become deuterium. And that process continues until they form helium, which is a chain of reactions that creates energy and allows stars like the sun to shine. So this process is called quantum tunneling. It's similar to tunneling that Schrödinger and other physicists found in atomic physics, and Gamow applied it to nuclear physics. And Gamow's theory was developed overnight, surprisingly. He was an amazing thinker. He developed it just in one day, and presented it the next day to Eugene Wigner, who was amazed. And it was also used not just to explain fusion, but also to create powerful particle colliders that could smash atoms together. So Gamow decided at a certain point to escape the Soviet Union because Stalin was clamping down on science, and Gamow could not really be a free scientist there because of the Stalinist oppression. So he and his young wife, nicknamed Rho, R-H-O, decided to escape first via the Black Sea. So they took a kayak, rubber kayak, and loaded it up with brandy and chocolates and tried to escape that way. But that didn't work because there was a stormy weather and they had to turn back. But luckily, Niels Bohr managed to get Gamov an invitation to the 1933 Solvay conference. And Gamov managed to wrangle an invitation for his wife because she was a physicist. So both of them traveled out of the Soviet Union to Denmark and then onward to other parts of Europe. Marie Curie took them in Paris at one point, and they never returned to the Soviet Union. Eventually, they went to the United States. Now, when they arrived in the United States, Gamov received an invitation to George Washington University, which happens to be in Washington, D.C., which is a city on the East Coast. But there's also Washington State on the West Coast. Gamov got confused and bought a ticket to Seattle, Washington, which is thousands of miles from Washington, D.C. Luckily, he was able to figure out that it was the wrong direction. He exchanged the ticket and managed to go to Washington, D.C. instead, where he became a professor of physics. Meanwhile, around the same time, Fred Hoyle, who was a brilliant science student we mentioned from Bingley, Yorkshire, managed to get past the entrance exams to get into Cambridge University and study maths and physics there. And he also became a professor at Cambridge. And that professorship was interrupted by World War II, where he served admirably in radar. Right after the war, he traveled to the United States for military business, but then he met with Walter Body, who was a great astronomer, and learned about Body's theory that supernova release the chemical elements through their explosions, and that supernova are the result of large stars of a previous generation called population 2 stars, which are made mostly of hydrogen, and at the end of their lifetime, their cores collapse catastrophically, and those cores explode and become the cores collapse. The outer part of the stars explode and become supernova explosions in that process. So the cores collapse, the outer parts become supernova explosions, and that sends elements into space, and those elements seed the next generation of stars, which are called population 1 stars, such as the sun. So Hoyle developed the brilliant idea that all of the chemical elements, higher chemical elements, are forged in dying stars, starting with carbon and all the way up to iron. And then beyond iron, all the remaining elements are produced in supernova explosions. This is a really brilliant idea that explains all the stuff that makes up you and me and everything around us. Everything from carbon to uranium can be explained through a kind of a ladder of building up these elements. So around the same time, Hoyle decided to take a break when he was in Cambridge and go to the cinema. And he saw a film there, The Dead of Night, with 2 of his friends, Herman Bondi and Tommy Gold. So you see a picture of Bondi, Gold, and Hoyle, and they were all astrophysicists. They worked together during the war on radar, and after the war, they all decided to turn their attention to astrophysics. Now, the film The Dead of Night is a rather gruesome horror film involving somebody who goes to a country house and has a foreboding that something horrible will happen there, and everybody kind of laughs it off, but he says, well, I really think something horrible is going to happen. And they end up telling ghost stories. And I'm not going to give away the whole film, but at the end, a dummy named Hugo plays a rather gruesome role, and some horrific things happen. But then the main character wakes up. It was all a nightmare. So he's happy that he's back in his house. seemingly nothing happened, but then he gets a phone call and is invited to that country house, the very same country house. So the film is a cycle, and he goes to that house and has the foreboding again. So things keep happening again and again. After seeing the film, the three of them, Bondi, Gold, and Hoyle, went back to Bondi's flat in Cambridge. And while there, they began to drink some brandy and talk about the film. And then Gold had a revelation. He said, what if the universe is like that? What if the end and the beginning are exactly the same and it just keeps going forever? Rather than having a cyclic universe, they came up with an idea in which the universe expands, keeps expanding, but new galaxies fill in the gaps. So as the universe expands, galaxies move farther and farther away from each other, but the old galaxies make way for new centers of activity. And in these centers of activity, new atoms form. These atoms get together and form new stars eventually over billions of years. Those stars ignite and get together and form new galaxies. So there are new galaxies filling in the gaps where the old galaxies have receded from. But that was not the only proposed way that year of making elements, going back to Hoyle's idea of making elements. That very same year, Gamow and his student Ralph Alpher proposed a way of making elements from a cosmic explosion. So this idea was very different from what Hoyle and Bondi and Gold came up with. Hoyle and Bondi and Gold's idea is called the steady state model of the universe. Gamow decided to take the Lemaitre idea and develop a hot Big Bang model of how the universe develops, how the elements develop. And that became known as the Big Bang. They call the model LEM, Y-L-E-M, for the Latin word for matter. And they published their idea in a paper. And Gamow was a prankster. So his student's name was Ralph Alpher. His name was Gamow. He decided to add Hans Bethe, another nuclear physicist, to the paper, just so he could make a play on words of the first three letters of the Greek alphabet, alpha, beta, gamma. And so it's known as the alpha, beta, gamma paper on nucleosynthesis. And it was published April Fool's Day. And it speculates that the hot Big Bang produced all the elements in its cauldron, that it was hot enough to produce everything from hydrogen all the way up to uranium. A very distinct idea, very different from the idea that the elements were made in dying stars. So you have, at that point, two competing proposals. Now, once they proposed this idea, they celebrated by toasting with a bottle of liqueur, which they relabeled as Lem, named after their idea of the substance of the early universe. And this cartoon came out after Alfred gave a talk about this idea of how all the elements were created. It turned out that their idea took place in only 5 minutes. So a cartoon came out in which an atom bomb contemplates how all the elements in the universe could be created in 5 minutes. But there's a problem with that idea. The early universe cools down because it expands. As it expands, it cools down more and more. So eventually, within those 5 minutes, it's too cool to allow for helium burning. Helium burning is a very, very difficult process to happen because you need two helium atoms, two helium nuclei to get together, form beryllium, which is highly unstable. That beryllium has to, in a flash, unite with more helium and form carbon. And that only happens under ultra hot circumstances, hundreds of millions of degrees. and through a quantum process that involves producing an energetic state of carbon. Now, the model by Gamow and his colleagues could not explain that, but luckily Hoyle's model could. He was able to explain that. 1949, the following year, Hoyle went on BBC Radio and coined the term Big Bang, and it's supremely ironic that he coined the term for the rival theory, and some say that he was disparaging the theory by saying Big Bang. He was putting it down, but some scientists who had spoken to Hoyle say that he claims that he was not knocking the theory. He was just trying to come up with a colorful way of describing it. Now, the two models of the universe competed for more than a decade in the 1950s. Both Gamow and Hoyle were master popularizers. They both produced their own books. Gamow produced a book called The Creation of the Universe, and Hoyle produced a book, The Nature of the Universe. And you could see that these were dirt cheap at the time. Something like, this would be something like 20 pence to buy the book. Very, very cheap books at the time. So many people bought these and had debates about whether the universe was Big Bang or steady state. In other words, whether it lasted forever or began at a point in the past. Gamow wrote popular science books, the Mr. Tompkins series. Hoyle wrote much science fiction, including The Black Cloud, which is a very famous science fiction novel. He wrote the screenplay for production, a television show called A for Andromeda, which was very popular. Gamow was a funny cartoonist. Here's an early parody of Mickey Mouse with Niels Bohr as Mickey Mouse. And here's a drawing he did of Teller and Ulam, the two founders of the idea of the hydrogen bomb. Hoyle wrote libretti for two operas with the American composer Leo Schmidt. You can actually see this on YouTube, Copernicus, narrated by Hoyle. So you might wonder why people were interested in the steady state model, which lasted forever, when today we think the Big Bang universe is rather obvious. But back in those days, estimates for the age of the universe were way off. Estimates, because of what's called the Hubble constant, was measured rather improperly. It was thought that the universe was about 2 billion to 3 billion years old. And the Earth is, of course, older than that. Most stars are older than that. So people advocating the steady state theory would say, how can the universe be younger than the stars and planets within it? It was a whole dilemma. So you had to be a real believer to believe in Big Bang and say, well, the estimates for the age of the universe must be off, which actually that turned out to be. Now we know the universe is 13.8 billion years old. Now the rivalry took place on an international stage. Pope Pius endorsed the Big Bang theory, much to the chagrin of Lemaitre, who said, do not mix religion and science. And the Astronomer Royal of the UK endorsed the steady state theory. So there was a great schism in some ways between the two theories. How would the battle be resolved? Well, in New Jersey, in the United States, a converted radio receiver for a communication satellite at Bell Laboratories in Homedale was converted to be used for astrophysics. Arno Penzias and Robert Wilson decided to apply that horn antenna to astronomical use, and this is still there. It's still on the site. And they decided to aim this at the Milky Way, the periphery of the Milky Way, and look for radio signals from the halo of the Milky Way, which they didn't find, but instead they found a persistent background hiss. And that hiss they recorded with this instrument, and they were perplexed as to what the cause was of the hiss. And they tried ruling out everything. They looked for noise from New York City, ambient noise from construction sites, and they even thought that it was due to pigeon droppings, which they called white dielectric material. And they scraped off the antenna, they scraped off all the pigeon droppings, they captured the pigeons in this very cage, which is now in the Smithsonian Institution in the United States, a museum, and still they still heard the noise. But luckily, they knew someone named Bernie Burke, who was an astronomer. Bernie Burke knew somebody who attended a talk by somebody named Jim Peebles, who was this fellow. And Jim Peebles was talking about his group, led by Robert Dicke, was trying to put together a radiometer to detect signals from a hot early universe. So Dicke had this idea that the early universe was very hot and that there was leftover radiation that formed a background hiss that had significantly cooled down to only a few degrees above absolute zero. And that's exactly what Penzias and Wilson found. Penzias phoned Bob Dicke. Dicke spoke to him for a while and then got off the phone, and he was with some of his students and said, "We've been scooped, boys. Somebody has beat us to our result." So they drove out to the receiver and verified that the only feasible explanation for the cosmic hiss was leftover radiation from a hot Big Bang that had cooled down over billions of years and was at that point only a few degrees above absolute zero. So that was considered the smoking gun for the Big Bang theory of the universe, and the steady state universe will never be the same. So this is not the picture they found, but much later, a baby picture of the early universe taken by a satellite, which showed some minute temperature differences. So it's not exactly the same temperature throughout. There's minor temperature differences due to structure formation in the early universe. Soon, the news that the Big Bang was verified was in newspapers around the world, such as in the New York Times. And Robert Wilson told me that's when he knew that his work was famous, when his father went to a chemist shop, picked up the newspaper, and saw that his son's detector was on the front page, and told his son, your detector's on the front page of the New York Times. And Robert Wilson was amazed and knew that his discovery was famous. Later, Penzias and Wilson would receive the Nobel Prize for the discovery. And much later, Jim Peebles would receive the Nobel Prize only a few years ago for his work in cosmology. Alpher and Gamow felt for the rest of their careers that they deserved more credit for the predictions. And in fact, Alpher had predicted a background hiss in one of his papers, or in actually several of his papers, and felt that they should have gotten credit. And at a conference, Gamow was complaining to people. He said, if you lose a penny and then somebody else finds the same penny, it's exactly the same, meaning if you come up with a theory and somebody else rediscovers that theory, it's the same theory and the original person should get credit for it. Hoyle briefly entertained the idea of a Big Bang, but then he began to ponder alternatives once more. He was very stubborn. He decided to develop something called the quasi-steady state model of the universe, in which instead of big bangs, there are little bangs, bangs in galaxies that produce the helium content of the universe, and there are iron needles floating in space that produce the background radiation. So he develops an alternative theory that he stuck to for the rest of his life. So this is called the quasi-steady state universe, developed with Jeff Burbidge and Giant Narlicker. And in his final book, Hoyle included this photo of sheep following their flock and, geese, I should say, geese following their group. And he said that it was the Big Bang adherents were like geese following a lead goose. So, and later Burbidge I met said it was a bit like lemmings following their leader over a cliff, which was pretty much the same idea. They said that you need alternatives. If you just believe in the standard theory, you're just, a mindless drone following the leader rather than somebody with a mind of your own, they said. Gamow died in 1968 at a rather young age. Unfortunately, he was plagued with alcoholism and died at a young age of liver failure. Hoyle survived until his 80s. He got into a rather bad accident. He returned to his native Bingley, and a few years before he died, and was taking a walk along a wooded path, and he slipped and fell into a ravine. And he was found the next day. He was unconscious, found by dogs, and he survived that luckily because of the search dogs, but he wasn't quite the same and died a few years later. So both were mavericks and brilliant thinkers until the end. So for more about these ideas, please consider picking up a copy of my book, Flashes of Creation, which is available in the UK as well as other parts of the world. And I hope you enjoy this. I'm going to stop sharing now.